Hello Year 12 single mathematicians. Now today's lesson is just a continuation of the previous one. In fact, it's just an EG number 2, which was subsection 1.5. I've just called it 1.5.5, which was to do with algebraic division, a method which we had done before. But now today's lesson requires you to do one extra thing at the end, and that is using partial fractions. So what we have got is we've got an algebraic improper fraction, quadratic on the top, quadratic on the bottom, so that's improper. And then the right hand side looks at first glance like a quotient and a remainder, but the remainder has been split into partial fractions. So we have quotient, and that part there is the remainder over x minus 1, x minus 2 split into partial fractions. So you need to know the sequence of steps would be to use long division to write it as a quotient and a remainder, and then use partial fractions to split up the remainder into these two separate fractions. So this is worth quite a few marks actually in an exam, and each individual step is pretty straightforward. It's just you need to know what order to do them in. So the first annoying thing is when using long division, they don't like factorized forms. So the first thing I'm going to do is rewrite what I'll call f of x in an expanded form. So just going to expand the brackets, x squared subtract 3x plus 2. Okay, now make sure I lay out the long division correctly. So x squared minus 3x plus 2 goes on the outside. 3x squared subtract 3x minus 2 on the inside. And again, remove the first column. That's the only thing you can do by timesing by 3. Plus 6. Do the subtraction. First column disappears. Negative 3x subtract negative 9 is an addition, so that's 6x. Negative 2 take away 6 is negative 8. And there's nothing to bring down, so that is your long division done after one step. So in other words, f of x is equal to the quotient plus the remainder over what you were dividing by. And last lesson we stopped there. But now today we have to do one extra step, which is split the remainder into partial fractions. So let's just pick on this first, which is 6x subtract 8. Now before I rewrite the denominator, for partial fractions, I like the factorized version of the denominator. So I switch back to x minus 1, x minus 2. I'm going to guess what the answer is going to look like. They kind of give it away in the question up there. I'm going to use the same letters as they did, but you could use any letters you like. B over x minus 1 plus c over x minus 2. The method for partial fractions, this is a type 1 partial fraction, the easiest type. You write everything to the same common denominator, x minus 1, x minus 2, and the numerators would change to b x minus 2, c x minus 1. And then effectively you just forget about the denominators and you are left with 6x subtract 8 is identical to bx minus 2 plus cx minus 1. And then you make use of the identity symbol. The identity symbol means this works for every single value of x you pick. So if you pick some specific values, let's pick x equals 2. You'd get 6 2's, subtract 8. Picking 2 is good because this entire term disappears, because you'd get b times 0. And this term would go to just c, to give you c is equal to 12 take away 8 is 4. And the other good x value to pick would be 1, because that would make the second term disappear. And you're left with 1 minus 2 is minus 1, so minus b. To give you b is equal to 6 take away 8 is negative 2. Swap the signs, plus 2. So you've got everything now to go back to the f of x, to say f of x is equal to 3 plus those fractions split into partial fractions, 2 over x minus 1 plus 4 over x minus 2, and that would be it. The questions I'd like you to complete are on page 18. This exercise 1G. And if you could try all of the, let's go with the evens. So try all of the evens, please.